Good morning, students. Today we are going to discuss about software economics. The software economics are known as some basic parameters which are going to be estimated before going to build the software project. And the software economics play very key and essential role for the entire development of the software project. And these economics are estimated, measured by software architectures and software analysts. Sometimes it is estimated by software managers also. The importance of software economics are it guides, it controls the overall running of the project. So with the help of software economics, the software project is going to be built every day or day to day. They will check whether the project is going on smoothly or not. That is determined with the help of software economics. So these are sometimes known as indicators. So all these indicators helps this development team or the software project management. They provides a roadmap for the entire success of the project. Okay, right. So there are five software economics. First one is size. Size is nothing but the number of source instructions or number of source lines in the entire project. It is also known as SLOC. Size is also known as SLOC. Please remember the word SLOC. SLOC means source lines of code. The total number of instructions appeared are going to build inside the project is known as size of the project. Second, process. Process is nothing but the modules or the total set of modules or the entire internal process statements is known as process. It is nothing but the statements which you are going to use in a particular requirement is called process. Then personal. Personal is nothing but the number of people, the number of software professionals, the number of teams, the number of software developers which are going to involve inside the project in stage by stage is known as personnel. For example, the project needs 50 personnel, 50 staff members, 50 professionals. All 50 professionals are going to utilize in different stages, in different levels. So all that are measured before going to build the project, right? Then environment is nothing but the tools and supporting technologies are used to build the project. It is also known as automate process. Whatever softwares, whatever supporting tools and techniques required is known as environment. Generally, the environment is situated inside the development side. For example, I'll tell you one small example. If you want to build a software project, you need the essential tools are computers, laptops, and internet and other network facilities, other resources are required. These are known as environment. It also includes softwares also. Then last one is quality. Quality is at most important parameter. The client always expect a good software product for his business. So the development team, the development side, they need to give assurance that they have to build a good quality product for the customer. Customer satisfaction is at most important. How a quality product will come? The software product quality is based on performance, reliability, adaptability, security. There are so many features are there related to quality. The quality achieved in controlling the project, and the management always go through schedules. Whether all the team members are doing the work or not, they have to keep on testing. They need to continually observe whether the product is built as per the requirements or not. That is thoroughly verified. So these 5 parameters are called software economics. Okay. Now 3 generations of software economics we are going to discuss in this slide. 3 software economics. Okay. The software economics, 3 generations. The first generation is 1960 to 1970. This is called conventional model. During this period, the software projects are built with 100% customization. All software works done customization. Every piece of code written by the software development team, 100% is called customization, and process is called ad hoc. And the models which were used in those period are known as waterfall model, functional design, uh, diseconomy of scale. So diseconomy of scale means there is no guarantee for success of the project. That means suppose the cost may exceed or a cost schedule may exceed. That's why it is known as diseconomy of scale. Diseconomy means the economy of the project may not give any assurance. That is called diseconomy of the scale. The first generation is called conventional model, and the second one, 1980s to 1990s, called transition period. It is a bridge between conventional to modern. Modern is after 2000 onwards, the software development process called modern practice. Third one is called modern practice. Now all software companies today are following modern practice and principles. Today, if you see all top MNCs like TCS, Infosys, Tech Mahindra, you took any software MNC, they are following third generation principles and third generation practice system. That is after 2000 onwards, major software companies they are following this method. In between conventional modern, the middle one is called transition. Transition is a bridge between both. Now we'll discuss about transition practice. So process improvement, encapsulation based diseconomy of scale. In this one also there is no guarantee for the returns, ROI, return of investment. No guarantee for return on investment because there is no 100% assurance that the product is going to be released with a success. That means within the budget, within the schedule. And the environment tools of the shelf separate size. 30% is component based, 70% is custom. Now I will tell you what do you mean by component based and customization. Component based means ready-made components, ready-made modules are available. Customization means every line of statement should be written, should be developed by the developer. And the process called repeatable. Repeatable means the process is done like iterative model. And next, last third generation, 2000 onwards, iterative development, component based model. So most of the projects today are running with the component based model only. Here 100% return on investment is possible. ROI, already I told you in the previous uh, generation also. ROI means return on investment. Whatever you are investing on that, you will get an returns. That means project is going to become success. Environment and tools off the shelf integrated. Size 70% is component based, 30% is custom. 70% of entire project work is done with the help of component based. Component means small modules. These modules are available immediately or ready-madely they are available. You can buy or you can take from third-party vendors. The project components are available easily. So we will use ready-made components 70%, 30% of components you are going to build. The company is going to build only 30%. Their effort is 30, 70 is available. Both they will mix together. So process managed and measured. Okay, let us see typical project performance, how the project performs. Um, Predictably bad. So, conventional model says you can't predict 100%. So, over budget, over schedule. Coming to the middle, unpredictable. Definitely on budget, on schedule. In modern practice, the last generation, third generation, definitely gives assurance that predictable, usually on budget, on schedule. So definitely the project goes to success and it gives you definitely a return on investment. So dear students, once again, it is very important. There are three generations of software economics. First generation is called conventional. Conventional period is 1960 to 1970. Middle one is 1980 to 1990 is called conventional. Conventional means it's a uh, conventional is known as transition. Transition means it's a bridge between conventional to modern. Old one is called conventional. The latest one is called modern. In between that, middle one is called transition practice. Last one is from 2000 onwards is known as modern practice. Today, all software companies they are following third generation principles. Okay, right. So in next class, we will go for pragmatic cost estimation model. How to estimate the cost that we will discuss in the next class. Okay.